Bismillahirrahmanirrahim. Today I'll talk about the two-port networks. So two-port networks is important when we like to know what is inside an integrated circuit, let's say, or any linear circuit that has no independent source in it, and we want to know what is, we can characterize this port using different parameters, either Z parameters, Y parameters, H parameters, and G parameters. First I will start with the Z parameters. So let's say we have two-port networks. So this is the two-port networks. This is the first port, and this is the second port, right? So let's say this is V1, and that is V2, and the current here is I1, and the current here is I2. So we'd like to characterize these two-port networks using Z parameters. Let's say first we have Z parameters. So we can, if we just use this for the Z parameters, two-port networks here. So we apply current, let's say here, I1. So that would be I1 here. And we measure the volt V1. We apply current I2. And we'll measure here V2. Now, we can use superposition, so we can say V1 can be written in terms of I1 and I2. So we can say V1, let's say, equal to K1 I1 plus K2 I2. Now, this is volt, so this must be volt. We have a current, then this should be Z. This is a current, this should be Z. So we can say V1, the same thing, we can say V2 equal to K2 I1 plus K2 or K3, let's say. Okay, so we have now K1, K2, K3, K4. These are the parameters. V1 depends on I1 and I2, and V2 depends on I1 and V2 depends on I1 and I2 as well, right? So this can be written as you can see, this will be Z, because Z times I is V, so we can simply say V1 equal to Z11 I1 plus Z12 I2, okay? Or Z21, depends on I2, Z21. And V2 is equal to Z12 I1 plus Z22 I2. So these are the parameters. So you can see here, Z1 is V1 over I1. So that's Z11, V1 over I1. And this one is Z12, sorry, Z12, and this is Z2. So V1 over I2. So the first I is for the one here, Z1, 2 is the current here. Similarly here, Z21 is V2 over I1, Z22 is V2 over I2. So these are the Z parameters we can find. Now from here, if I want to find from this equation here, so let's rewrite it again. This is the Z parameters. Z parameters. So we said that V1 equal to Z11 I1 plus Z12 I2, and V2 equal to Z21 I1 plus Z22 I2. So again, here we have V1 depends on I1 and I2, and V2 depends on I1 and I2. Now what is Z11? We can say now Z11 equal to V1 over I1 when I2 equal to 0, meaning I have to set this back to 0, and that will give me Z11. And Z21, same thing, Z21 is equal to V2 over I1 when I2 equal to 0. That is this. Huh? So you have these two because they depends on I1, it means I2 equal to 0. And the other two here, we have Z12 is equal to V1, that is the one for this, over I2 when I1 equal to 0. And Z21, right? Sorry, Z22, sorry, and Z22 is equal to V2 over I2 when I1 equal to 0. So here we make I2 equal to 0 by setting it open circuit. Here we make I1 equal to 0 by setting I1 equal to open circuit. And that will give me the Z parameter. So the core is this equation. So you can write it in terms of matrix. The concept here, too, sometimes it is difficult to memorize this equation. So all you need to do is you can say, from the circuit as I said, V1 will depend on I1 and I2. So V1 will be Z11 I1 plus Z12 I2. 1, right? Current and volt. 1, 2, current and volt and current. Okay? And Z22 depends on I1 and I2 also. Then you can find the parameters accordingly. So let's take simple example. Just to find Z parameters. Okay. So the example is we have a network where we have 5 ohms, 20 ohms, 15 ohms. Okay, so these are the resistances here. This is the first volt, this second volt. So this volt here will be V1, and this volt here will be V2. And we have simply actually what we do, we apply a current I1, right? And here I2, okay, this is I2, because we said that Z11 and Z12 and Z parameter depends on the currents, I1 and I2, using superposition. So to find Z11, we said that Z11 is equal to V1 over I1 when I2 equal to 0. So this means we have to set this current equal to 0. It is open circuit, right? So there is no current there. So we have to see what is the relation here between I1 and V1, or simply we can find what is the equivalent resistance seen from here. So you can see here, you don't need to do any analysis. We can log into this direction, see what is the equivalent impedance here. We have this 5 in series with the 15 because there is no current here. So I2 here equal to 0, right? So these two are in series. So we have Z11 equal to 20 times 20 divided by 40. So that will give me 0 minus 0. And we have half, that will give me 10 ohms, right? So that is 10 ohms. So this is Z11, right? Now, same thing, I will use the same circuit because this, when I2 equal to 0, so I have to find now Z21. So to find Z21 is equal to V2 over I1 when I2 equal to 0. So I have to find the relation between V2 and I1. V2 is this one. Now, if I use this current, just call it I, whatever, I, let's call it, this I want here. So V2 is this volt, right? This volt, V2. Now I have to find V2 in terms of I1. I1 is this current, right? So this is the current I1. So I can tell that V2 will be I times 15. So I can say V2 equal to I times 15. But what is I? I, we can use the current divider rule to find I here. So this is equal to I1, right? Multiplied by 20 divided by the sum, right? Which is 20 plus 20, that is 40, times 15. So this will give me half here. So that will give me 7.5 I1. So if I divide now, Z21 equal to V2 over I1, and that will give me 7.5 ohms. So that is how to find Z21. So it is better to get this first, right? These two parameters, Z11, Z21, because we will use the same circuit here with I2 set equal to 0, right? Now to find the other parameters, right? So we have now to go for the other parameters. The other parameters, we have the same circuit actually. So we have this is 5, 15, 20. This current is I1, and we have to apply now the current I2 here, right? And we measure the volt V2. So we have to find the relation between I2 and V2. Since this is not branch circuit, now Z22, right? We can find it directly. So we can find Z22 directly. Like let's start with Z12. Z12 is equal to V1 over I2 when I1 equal to 0, right? V1 over I2. So that is I2 and this is V1 here, right? So again we have to do the same thing and find I1 in terms of I2. So we can say V1 is equal to I times 20. But I, we can get it using the current division rule. So it is I1 into the other resistor, which is 50, divided by the sum, which is 40, right? Times 20. So this again will give me 7.5 I1. So we can say that Z12 equal to V1 over I1 equal to 7.5 ohms. Okay? Now we have to find Z22. To find Z22 it is simple because we have the current, we have the volt, so the impedance from here, right? So it is V2 over I1, we can find it. Then it will be Z22 will be simply equal to 15 in parallel with 5 plus 20, which is 25. So it is 15 times 25 divided by 40, and you can just evaluate this. It will be Z22 9.37 ohms. So this this is a simple example for the Z parameters. And similarly, you can find the Z parameters for any other circuit or two-button networks. The second one is a Y parameter. Y parameters. So here again, let's say this is my two-port networks. This is port 1. This is port 2. But in this case, we have to apply a volt here. Let's say this is V1, and this is a volt V2. Okay. So the current here will be I1. Current here will be I2. And we write the current in terms of, let's say I want to find the current I1 due to V1 only, so I have to short out this. Then I have to find the current I2 with due to V2 only, so I have to short this, right? So again, we can write the following equation. I1 is equal to K1 V1 plus K2 V2. Now this is current, this volt, then this must be admittance, right? So 1 over Z or Y parameters. Same thing here. And I2 equal to, let's say we call it K3 V1 plus K4 V2. So K1, K2, K3, K4 are Y parameters, or we can simply write I1 equal to Y11 V1, that is V1 I1. So it is I1 over V1, okay? Plus Y12 V2. And I2 similarly is equal to y21 v1 plus y22 v2. So these two equations are used here to find the y parameter. So what you can do, you short this and find I1. Let's say I want to find y11. So we can say simply y11, I will find first this and these two parameters. y11 will be I1 over v1 when v2 equal to 0. And y21 is equal to I2 over v1 when v2 equal to 0. So these are the first two parameters. And then I have to find the other two here. Then we can say y12 is equal to I1 over v2 when v1 equal to 0. And y22 equal to I2 over v2 when v1 equal to 0. So it is better to find the first parameters, because in this we set v2 equal to 0, so one circuit we use here, and then we use the other circuit to find the other two parameters. And again, we can try a simple example just to illustrate what I have just said. So let's say we want to find y parameter for the following circuit, where we have simple circuit, right? This 12 ohms, 6 ohms, 3 ohms, right? Now this is our board V1, this is V2 here, right? And we want to find the parameters now, okay? So as I said, I1 equal to y11 v1 plus y12 v2, and I2 equal to y21 v1 plus y22 v2. So to find these two first, let's say we want to find y11, then it is I1 over v1 when v2 equal to 0, right? And y21 equal to I2 over v1 when v2 equal to 0. So what we have to do in this case, so to find the first two parameters, we short this, so we can draw the circuit as follows. Then we short out v2, right? So short it out. Okay, so we short the source here. We have a current here. This current is I2, and this current is I1. We have here V1. This resistor is 12. This one is 3. This one is 6. Right? And we have to find the relation between V1 and I1, and then we can divide. So these two are in parallel, right? So we can say V1 is equal to I1 multiplied by this resistors in series. So we have 12 plus 3 divided by 6, right? So this is equal to I1 into 12 plus 3, 6, 18, 2, right? So that is V1. So V1 is equal to 14 I1, or we can say Y11 equal to I1 over V1 equal to 1 over 14, right? So this is the first resistor, right? And the same thing we have to, this is Siemens, 1 over 14 Siemens. Same thing for this one here, so we have to find I2 as a function of V1. So keep this equation here, just I'll give it a number, I1, which is Y11 equal to I1 over V1. Maybe I will need it later on. Or I1 over V1 equal to 1 over 14, right? So we can express it. Now if I want to find I2 in terms of I1, I can use a current divider rule here. I have I1, right? So I can say minus I2 or I2 okay, I2 is equal to minus I1, which is the same here, right? Into the other resistor, which is 6, divided by the sum of the resistors, which is 3 plus 6. So that will be minus 6 over 9 I1. So that is I2. Lakin I1 is V1 over 14, right? But I1 is equal to V1 over 14. So if we substitute here, then we can write I2 is equal to minus 6 over 9 into I1, which is V1 over 14. This will become 3, this is 3, this is 2, this is 1, this is 7. So that will be V1 over 21. So we can find from which we can tell that Z21 is equal to I2 over V1, and that will be equal to 1 over 21. Alright? 1 over 21. So these are the two parameters when we set V2 equal to 0. Now we'll do the same for the other two parts. So the other two parts will do the same thing. So for the other two bars, we can say here, this is Y12 equal to I1 over V2 when V1 equal to 0, and this is Y22 when V1 equal to 0. So the circuit now, we have to set V1 equal to 0. It means we have to short this end, right? So we have to short this side. We have a current here I1, and we have the volt here V2. So we want to find the relation between V2, I2 and V2, I1. That is I2, right? Now as you can see, we can find Z22 very easily. Z22 equal to, Y22. We can find it very easily from here, right? So just we can find the relation between V2 and I2. So we can say that V2 is equal to I2 multiplied by 3 plus 6 in parallel with 12. So this will be I2 into 3 plus 72 over 18. That will give me 4 I2. That is V2, right? 72 over 7. So 7. So Z22 will be I2 over V2 equal to 1 over 7 seconds. So this is Z22. Now, if I want to find Z12, then I have to find I1 as a function of I2. So from here we know that this means I2 equal to V2 over 7, right? So keep it in mind there. Then we can just find the other parameter directly. So we can find I1 as a function of I2 and then substitute this. So I1 is equal to minus I2 times 6 divided by 6 plus 12, right? So this will be minus I2, this is 18 over 3. So minus 18 over 3, I2 over 3. But I2 is V2 over 7, so this will be minus V2 over 7 over 3. So this will give me I1 is equal to minus V2 over 21, from which Z21, here, I2, this I2. Z21 is equal to minus 1 over 21. Okay, so this is how to find the Y parameters for simple circuit. Sometimes you will have dependent source, and we said that dependent source are allowed to be inside the two-port network, but not independent source, or storage element, but we have to make sure that there is no energy stored in these elements. So if we have a circuit, let's say, where we have a dependent source in it, then we can still do the same analysis, right? So we can use the same concept here to find the y parameters. As the simple example I have here, where we have, assume we have the following circuit. This is a dependent source here, right? And then we have this resistor is 4 ohms, 2 ohms, 2 ohms. This current is I1, and this current is 3I1. And this is our second board, let's say. So this is the board V2, and this is the board V1, and we have to find y parameters. Okay, y parameters for this. So again, we can do the same thing here. So we can simply say I1 equal to y11 I1 plus y12 I2, and I2 equal to y21 I1 plus y22 I2. You have to be careful about this. Now first I will find this, and then I'll find these two parameters. So these two, we can write y11, sorry, v1, v2, sorry, v1, v2. So first here you can find y11 equal to I1 over V1 when V2 equal to 0 and y21 equal to I2 over V1 when V2 equal to 0. So we will short this terminal here and try to find again the current here is I1, I2, sorry, the current here is I2. And we have to find the relation between these two parameters, right? So let's start with the first one. So what we'll do, we'll short out V2, because from here we have to short it, we make it 0 there. And now we have to find the relation. Let's say this is V1 here, right? And we want to find the relation between V1 and I1. So if we use KCL at this node here, let's say this is node A, and we say this volt is V. So again, as you can see, from here to ground, this is from here to ground, this volt is also V, this volt across this is V. So if we use KCL, we can simply say that the sum of the current head, or the algebraic sum of current at nodes A equal to 0. So this means we can say I1 plus 3I1, because these currents are going in. Then we have this current is going out, this current is going out. Then we can say is equal to V over 2 plus V over 2. Okay? So this means we can write this I1 or 4I1. 4I1 is equal to V, because V over 2 plus V over 2 is V. 4I1 equal to V. Okay? 4I1 equal to V. So this is what? Now what is V? V will be V1 minus 4I1, right? V here, we can find it in terms of V1. V equal to V1 minus 4I1, right? So we can say 4I1 equal to V1 minus 4I1, or 8I1 equal to V1. So Z11, which is I1 over V1 equal to 1 over 8 seconds. Okay? So that is the first one. Now the second one is find what is Y21, so we can simply use the same circuit, right? So we know that we want to find now a relation between I2 and V1. So I2 is the current here actually, because this is entering here and then leaving the other side there. So we have to find a relation between I2 and V1, so that will give me Y21. So we have to find Y21, which is the relation between I2 and V1. So we have to find relation between I2 and V1. So we can say that I2 plus I1 equal to this. So this is because the current here is coming I2, so it is the same as I2 here, right? So we can say I2 plus I1 is equal to V over 2. This is the current here. So the current in equal to the current out, right? Lakin V is this, so we can find it in terms of I2, this volt. This volt, we have a current in equal to this current minus this current times this resistor. So if I want to find V, this question on this, yeah? From here, we have a current in, part of it will go here, part will go into this, it will make a drop V2. Lakin it will be in the negative direction. So we can say V is equal to minus sign here because the current is going in this direction. So I say I2 minus 3I1, 3I1 times 2. That's the value. So equal to minus 2I2 plus 6I1. So that is V. So I'll call this 2. Now if we sub 2 in 1, to get I2, we'll have it as is I2. Now we want I2 and V1. I2 is equal to, I2 plus I1 is equal to this, minus 2I2 plus over 2, 6I1 divided by 2. So this means this is equal to minus I2 plus 3I1. Okay. So this will give me what? 2, 6, yes, so. I don't need to write this, so we can say from here, from here simply we can say V over 2 is equal to minus I2 plus 3I1. So if we sub here, then we can say I2 plus I1 equal to minus I2 plus 3I1, or we can say 2I2 equal to 2I1, from which we can say I2 equal to I1. I2 equal to I1. From the previous one, I1 equal to 8 over V1. I1 equal to 8 over V1. So if we just substitute, then we can say I2 equal to 8 over V1, right? Or I2 over, I1 equal to V1 over 8, right? So I2 equal to V1 over 8, and hence Z21 equal to I2 over V1 equal to 1 over 8. Simple. So this is the same thing. So this is the the first two parameters here. Okay. Great. Now we have to find the other two parameters, which is y12 and y22. So to find the other two parameters, now we have to sort this. This should be sorted out, and here we have to apply the volt, that is V2, right? And we have to find the relations here. So we have y21 equal to I2 over V when V1 equal to 0, y22 equal to I2 over V2 when V1 equal to 0. Okay? So similarly here, we have to find the relation, right? So we can find V2 as a function of this. So if we use V2, we use a KVL here, then we can say V2 is equal to this volt plus this volt, right? So you can say it is, what is the volt here? It is I2 minus 3I1 times 2, which is this volt, huh? So forget about the sign. Now you can use the sign in the other direction, okay? You can use the sign in the other direction. So this volt will be this volt plus this volt, all right? Times 2 plus or plus this volt. So you can use the loop here, plus V, plus V. So this is the loop, which is this loop here. So we can go around this loop here, right? So V2 is equal to this volt plus this volt. This volt is V, right? Should be the way. This volt is V. So you can say, but we have this is 2 times the current here. This is V, and this is now is not V because we have V2 and V here, right? So we have to find the relation between them. So we can say V2 equal to, just if we open up this, V2 equal to 2I2 minus 6I1 plus V. But what is V? The current entering here is I2, so it means it must leave here as I2. So V, these two are combined in series, so we can in parallel. Sorry, so you can say V is equal to I2 into the parallel combination, which is 2 in parallel 4, right? 2 4 8 على 6. So that will give me 8 over 6 times I2, that is V, right? So if we sub, now we have V2 is equal to 2I2 minus 6I1 plus 8 over 6 I2. But I1 is minus V over I1, right? And V is 8 over 6. So, and I1 is equal to minus V over 4, but V we have it there. So this is equal to minus 8 over 6 I2, this times 4 here. So it is, if we divide, that will be minus 1 over 3 I2. Minus 1 over 3 I2. Okay, that is I1. So we can substitute here, and we have V2 is equal to 2I2. This minus 7 with minus will cancel, so that will be plus 2I2 plus 8 over 6 I2, and then we can simplify y21 if we divide, y22, sorry. If we divide, then we have y22 equal to 3 over 16 seconds. So that is for y22. Now to find y21, which is this one, it is I2 over V1. I2 over V1. So y22, we have to find the relation between I2 and V1. Right? I2 and V2, sorry. I2 and V2, sorry, when V1 equal to 0. Y21, I2 over V1. Y21, I2 over V1. So V1 is this port, right? Y21 is I2 over V1 over V2. When V1 equal to 0. When V1 equal to 0. So we have to find the relation between this is Y12 is equal to I1 over V2. So we have to find a relation between I1 and V2, right? So we know that V2 from the previous loop we have equal to I2 minus 3I1 times 2 minus 4I1, which is this one actually, because I1 is going in this direction, so this will be plus minus, so it is minus 4I1, so this can be reduced to 2I2 minus 6I1 minus 4I1, so it will be 2I2 minus 10I1, so that is V2. So we have to find here I2, right? I1 in terms of I2, so we can, as you can see here, I2 and I1. We can find I2 in terms of I1. So I1, this question, I1 equal to minus I2 using the current divider rule. Minus I2 into 2, that is the resistor, over the sum, which is 6, 4 plus 2, 6. So that will give me minus I2 over 3, from which we can say that I2 equal to minus 3 I1. Now if I substitute in 1, then we have V2 is equal to 2 into I2, which is minus 3 I1 minus 10 I1. So that will give me a 16 I1, that is V2. Or I1 over V2 is equal to minus 1 over 16. So this is the last part here. So this is how to find Z and Y parameter whenever you have two boards networks. I hope you understand this, so you can just practice this type of questions to find the parameters.